Hello friends, hello. So my name is Parvinder Singh. I'm a technical architect in the NEC Technologies India. And today I'm going to present some details over edge computing and also a use case demonstration for the same. So, okay, so I will be covering first a very short video on NEC Safer City Solutions, and then an overview to the workflow, and then what business values it brings, and then what are the differentiators it has, and at the last I will demonstrate a use case.
Today, society is facing major challenges arising from rapid increase in world population, inequalities in economic and resource distribution, and more. NEC is already working to optimize available resources to bring happiness to people, using biometrics to ensure meals for children, raising agricultural productivity via e-vouchers. Our desire is to work together with our valued partners and customers to co-create solutions that address social challenges to help realize NEC Safer Cities, creating a more safe and secure society for everyone, including watch list detection by facial recognition. Helping to build a society that offers equal opportunities and efficient services. Enabling a pleasant and stress-free lifestyle. NEC provides diverse solutions from the ocean floor to outer space. And its global operations enable co-creation on every continent. NEC is a global leader in ICT. Its unique #1 innovative technologies in biometrics and AI underpin solutions for society that create new social value. Together, for a brighter future.
Orchestrating a brighter world, NEC.
Okay, so coming back to again workflow. So, so what is workflow? So workflow is an edge computing orchestration framework, which is basically allows a context-aware processing and also allows end user to have a custom task programming model interface. So it means a user can design, program their own custom task according to their edge requirements. So how the workflow solving the problems? On the left-hand side, we can see that we have the IoT services, but it is difficult to program because of lack of modeling. And then on the edge side, when we go, then there is always, we find there is an infrastructure difficulty to manage. That's because of high complexity from heterogeneity and various dynamics that we have. And on the edge devices side or the end devices side, so we always have the problem that they are not able to smart, and because of that, that cannot be operate in a closed loop manner. So when we use NEC workflow framework, so basically this is the edge computing framework that allow us to mitigate all those problems that offers us the lower complexity with lower cost and with the higher efficiencies. So business value proposition for the same is that it allows the customer to adopt and leverage edge computing infra very fast. How it does that? So it allows the edge programming model, and then it allows optimized orchestrations, and it allows the fast control loop. And by doing so, it allows or enables the IoT service providers, infrastructure providers, or the device providers with the improved QoS capabilities, benefit of low learning cost, low operational expenditures, and then the most important critical factor is the faster time to market products. Differentiators for the same is that when you have optimized orchestrations, then you trigger dynamic processing flows at edges on demand. So basically, this is what I was talking of, this closed control loop. So you have connected devices and you can have your nearby edges. So basically, you can notify or you can sense the data and do some actions in the fashion of notification back to the devices using the nearby edges computing logics, and then those edges needs to be collaborated in a manner with the backend cloud components. Also, the advantage of this nearby edges is that, or the edge computing is that they can talk directly to the another neighboring edges. So in this way, there one can have the service chaining of edge nodes, and thereby they can utilize or they can design a service which can be catered at the edge side. So another is the agile programming model. So basically, a user can design or program a certain model, so build some blocks which can be reused in one-to-many fashion. So a user can design a certain certain programming models for one use case deployment, and then those can be modified for the multiple use cases. And once those are done, then those would be onboarded on the FogFlow systems, and once it is submitted, then your service is ready within minutes. So why FogFlow? So FogFlow follows the standard ecosystem. So it is the FIWARE GE now. So it is based on the open data model. So it offers open APIs, vendor neutral, easy federation. And you can deploy FogFlow in different domains. So for example, it can be deployed in smart cities, public safeties, and other FIWARE systems. And also, different domains can be federated, or different deployments can be federated with each other. So of course, that can be leveraged to marketplace of data-driven apps where one can monetize your data applications. So this is the use case I'm going to demonstrate. So let's say we have a lost child. It may be in a stadium or in an airport, which is equipped with edge-based video analytics. So let's say a child is lost and his parents come to the policeman and hands over the picture of the child to the policeman, and then policeman or give it to the relevant authority to send it or onboard that with the task of the face recognition into the FogFlow system, and then it will the FogFlow will orchestrate the algorithms related to finding the child detections, and then does the relative work. In the end, there would be the notification to the policeman or the relevant authorities where the child will be found. So let's see in minutes. So by doing so, FogFlow achieves, it finds the child very faster, and it reduces the 99% bandwidth as compared to cloud-based solutions, because at the edge side, obviously when you have your computation very near to your end devices, then the overall path cost would be lower. So because of the programming model, so you can program each task in your requirement, so it reduces the development operation cost. So this is the architecture for the FogFlow. So it has two layers and this red components, not going into much details. It has task design and topology master. And then there is a workers, which is the edge task initiated on the edge side. And these are the service topologies where we define different tasks related to the child detection. Let's see the child finders, and there are another use cases or another task, which is, for example, anomaly detections. And then these are the fork functions, which is the edge task. Basically, these are the tasks that runs at the edge side over the certain computation unit of the edge. So these are the different fork functions. Now we have here use case. We have onboarded the lost child use case. So herein we have two inputs to the face matching algorithm. First is the virtual device, another is the picture of the lost child. So if it is found, then child found notification would be returned. So in the beginning, we don't have any task, and also obviously we don't have any result. So let's say it is the management topology, so wherein we have handed over this picture to the lost child, and we have 2 cameras, each is feeding with certain video analytics, video capturing, and we are defining an interval of enhancing the geoscope for 5 seconds. For every 5 seconds, we will be increasing with 10,000 meters radius. So we are defining an area starting with, and then starting this use case. So now this geocircle will keep increasing after every 5 seconds till the time the child is not found. Once the child is found, the notification or the location of that will be notified. See, so herein we have found the child. So at the S side we have one task running, and on the result side it's telling us the time when it is detected, the exact image, and then at which camera it is detected, and the geolocation for that particular detection of the child.